So, now let us see Newton's law of viscosity. So, Newton found that the fluids which flow in, so he found that the fluids which flow in parallel layers suffers a resistance force. This resistance force is found to be proportional to the area of these layers and the magnitude of the velocity gradient normal to it. That means if the sheets, so this is the surface, static surface on which there is a laminar flow, so that you can see the liquids flow in these directions, sheets. So, suppose at this is the height, I say y, and this is dy. So, suppose here it is v and here v plus dv. So, we mean, so here velocity gradient normal to the flow is defined as this is dv by dy. So, according to Newton's law of viscosity, the force of friction between the two different layers is proportional to the area. This proportionality constant is there, proportional to area, and this gradient, that is dv by dy, implies, if I use the constant, f is equal to minus eta, this is a into dv by dy. So, you see here the proportionality constant is called coefficient of viscosity or dynamic viscosity, or we call it absolute viscosity, eta. So, this is eta. Now, this eta does not have a special name in SI units, but in CGS unit it has a special name called poise. Special name is there not in SI units. So, now this expression, if I bring this a this side F, then it will become F by A is the shearing strain. Now, we see this is the Newton's law of viscosity. We can further write in a different format, that F by A is equal to minus eta, that is dV by dy. This is called the stress. So, this is the shearing stress. So, you see here the liquid applies a shearing stress is equal to minus eta dV by dy, where negative sign indicates that the force is a resistance force. This force is a resistance force. So, you see this is the stress which the liquid will apply, that is the shearing stress which is applied due to viscous forces is found to be directly proportional to the velocity gradient of the fluid profile. Now, so you see this is linearly, thus you see thus the shearing stress is linearly varies with the velocity gradient. So, those liquids which obey this relation are called Newtonian fluids. So, you see this linear relationship is in the form of graph. This is here F by A shearing stress, and here the velocity that gradient. So, if this graph is linear, this will be a Newtonian fluid. So, those who deviate from this graph like this are non-Newtonian. So, these are non-Newtonian fluids. Example, tar, coal tar. Tar does not obey Newtonian fluid relation. So, those who obey this linear relationship between this strain and the velocity gradient, they are called Newtonian liquids, otherwise they are non-Newtonian liquids.